Hey guys, Professor Calculus is here, and I got a new integral for you today. So before we start, make sure to like and subscribe as it is free and you can always change your mind later. So to solve this integral, this might sound a little bit hard to solve, but I can do a little substitution here, a smart substitution. I'm gonna call t to be equal to arc sine of x. And if I take the sine of both sides, I'm gonna get sine of arc sine of x. And sine of arc sine of x is x, and obviously I'm gonna get x to be equal to sine t. If I differentiate both sides, I'm gonna get dx equals to cosine t dt. And I gotta change my bounds, do not forget that. My bounds when so my new t, so when x equals 1, arc sine of 1 is pi over 2, t is pi over 2, and x equals 0, t equals 0, arc sine of 0 is 0. So with this new method, I can change my bounds in this integral. So I'm gonna put the changed bounds in red, and sine e to the u, e to the t, sorry, cosine of t dt. So here, this integral right now is solvable. Obviously, you might remember integration by parts, where if I have a function like this, u dv, it is defined as the integral of uv minus v du. So here I can do integration by parts. I'm going to call this u and this part dv. So my u is e to the t, du is d to the t, e to the t dt. My dv is cosine t dt, and my v, if I integrated the integral of cosine t dt, is sine t. Now, I'm gonna write the integration by parts. So I equals e to the t sine t, the limit from 0 to pi over 2, minus the integral from 0 to pi over 2 of e to the t negative cosine t dt. Oh, sorry, I meant to write sine t dt. Now, if I calculate this limit, I'm going to expand it. It's going to be e to the pi over 2 sine of pi over 2 minus e to the 0 sine of 0 minus this new integral here, e to the t sine t dt. So sine of 0 is 0, and sine of pi over 2 is 1. Thus, this is going to go away, and I'm going to be left with, sorry, I to be equal to e to the pi over 2 minus the integral from 0 to pi over 2 of e to the t sine t dt. Now, I can do the integration by parts again here. If I do that, I'm not going to write it right now here, but just to say this is my u and this is my dv. My u is e to the t, so I'm going to write e to the t, and the dv is cosine t, the limit from 0 to pi over 2 minus 0 to pi over 2 negative cosine t e to the t dt. And this limit, if you calculate it, it's going to be equal to 1. It's e to the pi over 2 minus 1 plus 0 to pi over 2 e to the t cosine t dt. And if you pay close attention, you're going to see this is my I, the integral that I wanted to solve here. That's it. And I'm going to write I equals to e to the pi over 2 minus 1 minus I. And 2I is going to be e to the pi over 2 minus 1. And I is equal to e to the pi over 2 minus 1 over 2. Therefore, I've solved my integral, which means that my integral from 0 to 1 of e to the arc sine x dx is e to the pi over 2 minus 1 over 2. And that concludes our today's integral. Hope you enjoyed this video. Please like and subscribe, and I'll see you next video.